My name is Jo McIntyre. I'm a team leader at EMBL EBI, where I run a database called Europe PMC, which holds the open scientific literature. There's about 30 million abstracts, 5 million full-text articles that are open for everybody to read. Scientific publishing is the currency of life science culture. It's the means by which scientists tell the world about the work that they've done. Traditionally, when you published your papers, there have been scientific journals, and there are thousands of scientific journals, millions of papers in thousands of journals. And the typical way that you would access those outcomes of research would be to pay a subscription to the journal, and then you'd be able to read the paper. And I was about to say recently, but actually it's now 20 years, a new model of publishing came along called open access. And this is different to the subscription model because in this model, when you publish a paper, you also pay an article processing charge. And when you pay that, you effectively open your paper up to the world. Anyone can read that paper. And with the correct license, called a CC BY license, anyone can reuse that paper. So open access is important for a number of reasons. One, it allows everybody to read the research, regardless of their income or where they're located. And two, it will allow us to develop algorithms to help us find things in the literature more easily. Even with the best of intentions, it's really hard to find the relevant papers when you typically do a search and you'll get 2,000 papers back. You're never going to read 2,000 papers. So in the future, if we have a more open publishing system, then I would hope that that would build trust in the system with respect to scientific reproducibility. If you can read the paper, you can access the data behind it, then that's going to be more believable. But also, we've got quite a lot of power now in the development of algorithms, deep learning, machine learning, text mining. And when those algorithms can run on a much larger corpus of full-text articles, then we will be able to invent better ways to read the papers. If we can develop better ways to read the research literature, then this is going to speed up science. At the moment, it's an impediment to science to not be able to find all the things we need to in an efficient manner. Another new development in the world of publishing, life science publishing, is the popularity in preprints. So typically when you would publish a paper, you would send the paper to a journal, and then a long process sometimes of review and revision happens behind closed doors before the paper's published. With preprints, as a scientist, you're deciding when to publish that paper. And as a result, that means that you can make the outcomes of your research via this preprint available much, much earlier. Alongside the interest in preprints in biology, there's another thread to this, which is the publishing of peer-reviewed materials. So this would allow even more transparency on the publishing process. How do we get to a point where universal open access is the norm? Well, of course, policies are important alongside infrastructure to support that. But also we really do have to think carefully about how developing nations would be able to afford open access if they have to pay for every single paper they publish. EMBL EBI's traditional strength, if you like, is in the management and availability of open research data. EMBL EBI runs many databases that support life sciences research. And perhaps relatively recently we've added the literature database, Europe PMC, to this suite of services. We like to think that Europe PMC is a platform for innovation. That means supporting people who want to do computation on the literature, so text miners and machine learners, giving them the literature in ways that they can easily use, with APIs and the correct formats, standard formats. And then we have the means to also publish the outcomes of that text mining for everybody to see. At the moment, open access accounts for 25 to 30% of papers in life sciences, and what we really want for the future is to see that proportion increase. Can you imagine where genome science would be if all the data weren't open, weren't in the appropriate infrastructure to support access, didn't adhere to data standards? Where would we be in pushing genomics into the clinic if access wasn't open and in the public good?